Today's session is on wall positioners, control wall positioners. Actually, control wall accessories, control wall roll, uh, everything. I think last semester we have discussed. Now we are talking about a very important part is the positioner. And as you know, control wall positioner, uh, there are four generations happen so far, or we can say evolution started from pneumatic, or before that hydraulic, pneumatic, then hard positioner, filbus positioner, and now we are talking about wireless positioners. So we'll see the about that positioners role. In this picture you can see this is the control picture, wall body, stem, yoke, and this is the positioner part here. You can see here, this is the positioner. If you see the cut portion, all other accessories. So this part is a positioner part, and we are discussing, or our session is concentrating more on this part. If you see the walls in the industries actually installed, you see this pipeline, then isolation walls, and this wall you can see high pressure wall, high temperature wall, and you can see this is the positioner here. This is the hard positioner, and you can see the linkage to the stem is here. It is slightly visible, or you can see back side or rear side of this. This is the stem where you can see it is the link to the positioner mechanism here. So we are going to discuss on this now. And this is the electronics of the hard positioner, which are indicating your percentage wall opening here. And this is the graphical screen on the DCS. Uh, Now we'll see one by one. First, we'll see pneumatic positioner, then hard positioner, then filbus. And this is the way evolution has happened in the industry. So latest is the wireless. So if you see the control wall and positioner relationship, DCS controller send the output 4 to 20 milliampere, goes to the field, and that is processed by positioner through, if it is a hard positioner directly, it is coming. If it is a pneumatic positioner, it goes to the I2P, and then 3 to 15 psi is coming. So this is the positioner here, and positioner takes air supply. Pneumatic positioner takes air supply, electrical input, and control pressure is here on the wall, and this is a control signal which control the position of the wall, and the present position feedback, which I have shown you earlier slide in the linkage. Through this link, I will go back and show you this link. I'm talking about this link. This link, actual position, or the position link, is the input, very important or crucial input to the positioner. This one. Hmm. So if you see the relationship, the positioner needs three inputs. One, air supply, second is controller signal, and actual position of the wall, that is the position feedback, and then you will get a control pressure output here. So sorry. So control positioner, if you see the function, the wall position is the servo amplifier used with the wall actuator. So it is acts like a servo amplifier. It's amplifying. Wall positioner assure that the control wall stem accurately takes the position that the input signal command. So if you see whatever control pressure signal comes at the same pressure, suppose it is a 3 to 15, maybe 12 psi, or maybe 9 psi, so that position wall has to always maintain. So that is a very important function of the control wall. So wall positioners, as we are discussing, pneumatic. positioner, electrical positioners, hydraulic positioner, actuators means positioners. So if you see the electrical actuators mainly consist of electrical relays, solenoid, stepper motor, AC DC motors. So this forms the electrical actuators. So normally it is for high end heavy duty applications, not like oil gas, like, but heavy duties in the cranes or in the minings. So there you can find electrical actuator or hydraulic actuators. So pneumatic and hydraulic actuators enable large forces to produce from relatively small pressure change. So here with a small pressure change that controls the large force. That is the main function of the pneumatic and hydraulic actuators. So this is what is a relay. Relay we will discuss later on, but relay is you can see electrical heater contact. One contact is here. Relay has a coil, and through that magnetic fields you can have NO and NC contact. So that is the what electrical heat relays are working. So in the electrical category, DC motor actuators, solenoids, they are coming in the pictures. So this is what a field wiring. This is a field wiring. Output from the controller. Output from the controller, and the constant voltage, constant like this. You get field wiring, and this constant voltage through this solenoid wall, plunger, spring, output input from the controller here, and this is a coil and plunger. Means this is a solenoid functions. And through solenoid, the piston is moving, and the piston position is linked to the this wall. So this type of mechanism is there in the electric type of actuators. So you can see here uh, integral attachment of accessories. Wall is showing attachment. Here you can see attachment as, oh sorry, you can see here. This is the link, and this is your positioner. This way the attachment is there. This is, so this is the position link. Same at back side it is there. So in this stem it is the attachment is here somewhere. So this is the positioner, and the positioner you can see the air supply is required. So here indicators are there. So control calibration, if you see here, but positioner is attached here. Will this control wall problems, causes, and solution we'll see later on. First, we'll discuss on the positioners. So you see the wall positioner improves the linearity and a small input signal required. This is very important. With a small, see 3 to 15 psi signal coming, or 4 to 20 milliampere signal. With that, you are controlling high pressure walls, and they are linear. Wall position is not like on off; they are linear. Used with the wall actuator to assure the control wall. To assure the control wall stem accurately takes the position that the input signal. So with the linkage, it takes the required position, control position. But so if you see here without positioner, with positioner you get a control wall stem accurately takes a position that the as per controller requirement. However, without positioner, the stem position is affected by varying the fluid pressure on the plug and by unpredictable friction losses. Means if the positioner is not there, then you will not get a control pressure. Suppose at the input side wall pressure increases, the automatically it will lift the stem. So it is not, we cannot say it is a control. So for controlling flow pressure, the wall position is required. positioners are not required for on-off service. If you require only on and off, also positioner is not required. Improves the control loop performance, increases speed of response. Input signal increases, cam moves stem upside, but because of air supply and position of wall, the stem moves downside and stem is balanced. So slightly this slide is not edited, but you can see in this slide control wall positioner, why it is required. It is required because you require stable controlled flow rate. That's all. If the positioner is not there, then you will get your flow rate affected based on your input side pressure increase of the wall. So in the electro-pneumatic force balance positioners, basically, uh, if you see the pneumatic system, in the force, how the force is balanced or motion is balanced, always you see electro-pneumatic force balance positioner. You have a coil here. You see here, and coil, and this is a magnet. So ring magnet here, right? And what is happening here, you can see here, input current, balance beam, this is a pivot, this one, this is a nozzle. See, feedback system how was developed in the pneumatic or mechanical system. You can see the this air, if you see here, air supply is coming here in this wall. This is a wall basically, or we can say pneumatic relay. You see here, here is the 20 psi is coming here. Then it is a relay wall. What is happening, uh, based on the current, input current, magnetic field is generated, and the gap between this is based on the input current 4 to 20 milliamp, and feedback pressure is generated, and this through relay, and it forces here, relay here, like this. So this is a feedback spring, and wall get a original position with the help of feedback spring. So this is the what control wall stem with the electro-pneumatic force balance position. This is a wall. Motion balance, this type of positioner you can see here in the electro-pneumatic. Input signal, again here same thing. Pivot, this is the flapper, and this is a nozzle. So this is a flapper nozzle system, air supply, relay, and this is stem. Just a minute. So you can see here, in the positioner, pneumatic positioner, relay is very important here, and we call as a flapper nozzle system. Through this, it is there. Then another is a force balance amplifier. So there are earlier various types of pneumatic positioners based on the your functional requirement of the plant. So here you can see this is the wall here, spring control wall, and this is the link of the control wall, and through this cam it is connected to the this mechanism, feedback signal, and it is a balance. The position balance, same thing. Here is a wall, this is a wall, stem, fixed pivot, flapper nozzle system here. So these were earlier mechanism, and still in the pneumatic positioner it is there. This part, flapper nozzle system or relay. So you can see here, this is a wall stem. This is the link. It is a through spring. It is a connected to the pivot, and input displacement of this across the nozzle, and air supply, back pressure is generated. So this is the what wall here. This is a picture of intelligent wall, means a smart positioners. This is not pneumatic positioners, field bus and hard positioners. You see, this is the picture. This is the what positioner is there, and this is the control output. So field bus position, or if you see in the plant, this is a fissure wall, and you see this positioner is installed here. There are two indicators which shows here air supply of this and output, control output, output to this. Above this, you can see their backside link is there. So this is a field bus positioner, field bus wall positioner. This one you see here on this wall, you can see the connection, field bus connections through this termination box. This is a spur cable. Before going to the foundation field bus features, I'm first discussing hard positioner. So hard positioner first we'll discuss. I'll coming back to this picture. Hmm. So smart means heart. Heart is the communication protocol. So based on a heart communication signal, the wall positioners are designed. Therefore, it's called a heart positioner. So I have shown in the plant picture also their heart positioner from Siemens was there, and there are few other manufacturers positioners are here. You can see one, two, three, four. So field view, wall link, Emerson has a positioner. Honeywell has a SVI 3000 series. Sipart PS is a Siemens that we have shown. Smar has a FY. Dresser has a wall, and Samsung has Samsung 370. So these are the model numbers of the smart wall positioners. So if you see here, diagnostic features and diagnostic benefits, there are various or important features available. Wall positions you can get in the digital format. Historical reading you will get. Total travel recording you will get. Stroking speed you will get. Wall deadband and hysteresis also you will get it. And actuator bench range. So these earlier were not available. If the wall is not working, wall is passing, leaking, or calibration requirement, you have to remove the wall from the line. And it is a very we can say for critical walls, sometimes you have to stop the plant. And in the control walls, you can see here, control wall is a field device, transmitter is a field device. So in instrumentation or in a plant maintenance budget, input side means wall, transmitters, around 30% your time is spent on the transmitter maintenance. However, your 60% time is almost spent on the control wall maintenance. So your budget, annual budget for maintenance is more on the almost more than 50% budget is for control wall. So control wall is very very important, and less than 10% budget for your maintenance is required for your automation system in the control room. So then you will understand the importance of control wall. And because you are using more advanced wall positioner, you minimize the downtime, minimize the maintenance budget on the control wall, right? So that is the what the technology is moving fast, and it is adapted in the industry. So if you see the any smart wall positioner, this is your controller, and this you can see here we have discussed. This is the link is there, position link, position feedback, and you can see the set point or current or pneumatic input is coming from the control room or I2P, right? And you can see the block diagram here where you can have PID also, other pneumatic circuitries are also there. I2P is also is there inside inbuilt, error indicators. So first we'll see the wall positioners. Normally in the wall positioners of any manufacturer, you can see these are the manufacturers. So first you have to see that 4 to 20 mm signal, HART signal means pure analog signal, HART signal, foundation field bus, Profibus, external digital display, non-contact coupling, X-proof, intrinsic safety, and microprocessor base. These are the standard, or we can say important specification for the smart wall positioners. So you have to define your wall is giving 4 to 20 milliampere hard or foundation like this. Then this is the what related to electronics. Furthermore, about the mechanical part, stem travel, shaft rotation, pressure supply, temperature limit, sensitivity, repeatability, hysteresis, air consumption, and output capacity. These are the additional specifications for the smart positioners. So this slide is very, very important to understand the wall positioners. We can say smart wall positioners. So this is a mechanical schematic. You can see here, electronics is here, and from this electronics there are so many outputs, inputs generated. Interfaces are also available with the DCS, either through these sync commands or hard signal or RS485 Modbus. So just see here, this is your wall. This is your wall picture, and in this wall you can have a measurement. You can see upstream pressure, downstream pressure P1 and P2. That signals are sensors are there. Then one more sensor is for temperature at the uh, disk, plug and disk position, means actually where your seat and plug is there. So there you have temperature sensors. So three important sensors are monitoring parameters are there. Through that, diagnostic is programmed. Algorithm is developed based on these inputs. Then you can see this is the positioner part where position position link is there. So position sensor is there. So stem position you see here. Stem position, one of the input goes to the controller, which normally is the basic function. This is one input. Then top pressure and bottom pressure here. That is on a wall uh, above the diaphragm and below the diaphragm. This pressure. That signals are also there. Pressure sensors are there. And you can see here, air supply is a external, goes to the I2P. So with these inputs, stem position, bottom pressure, top pressure, upstream pressure, downstream, and temperature, the algorithm in the microprocessor is developed to get the diagnostic, which we indicated earlier. And this electronics gives a various digital outputs or to indicate the health of the control, this control wall. So this is what, and this microprocessor gives the command to the I2P for the for actual internally it is there. So this is the what wall positioner is. So intelligent control wall system. First of all, what does intelligent in a control wall system mean? There has been some confusion in the use of the term smart and intelligent. The smart generally means the device has a digital microprocessor that can talk to a host over a digital communication protocol and can handle simple tasks such as diagnostics and calibration. We have defined intelligent to include smart devices, but also to cover a device that can perform all three actions of a control loop: measurement, control, and process regulations. Means this intelligent, smart means simple tasks such as diagnostics and calibration, which HART protocol we use to get it. But intelligent means it will measure, it will control, and regulate also. So acts as a controller. That means intelligent. So these all also should be able to monitor the process and bring it to a safe condition if there should be a failure or upset condition. So intelligent control wall, as it has a control facility, it it safely shut down the wall. We generally have found that intelligent offers a significant benefit in three areas: performance, maintenance, and safety. So when I am saying a wall is smart, smart means based on HART protocol, it is a smart wall. Based on field bus or foundation field bus or profit bus, it is intelligent wall. That is what and what is the intelligence means? It will measure, control, and regulate. And what is the smart means? It will do the diagnostics and online calibration. So this is what you understand now. So we are talking here features of the intelligent control wall system. At the minimum, the intelligent control wall must have a sensor that measure the process temperature, upstream and downstream pressure, fluid flow rate, and all the wall conditions means stem position, cylinder pressure, positional characteristics. So I have shown in the block diagram. See these inputs. You can again check this: temperature, pressure, stem position, and these are the cylinder pressures, means above and bottom. Then it needs a powerful microprocessor to analyze these conditions and to handle communication with a remote computer or your host DCS system. Means then controller has to, this positioner has to communicate or communicate with the DCS, needs a microprocessor. So that microprocessor means electronics you have seen in the block diagram. The program in the microprocessor, that is means algorithm developed in the microprocessor, must be capable of acting as a single loop controller. This is very important. It acts as a single loop control means PID controller, interlock device, diagnostication, calibrator, and backup services. So all these functions are incorporated in these walls. So you can see in the diagram again, the interface with the DCS modbus. Then with these signals, DIDO, AIO, AOs are there, DOs, DI, and DOs are there. You can have a interlock in the safety interlock to be developed. Hmm. Applications of intelligent controls wall system, where these walls are applied. as you know, this is acts as a controller. The original application for this control wall system was those processes that had higher labor cost, expensive process materials, and very sophisticated control needs. Means these walls were used only for higher labor cost, means where you require very experience and higher cost when cut comes, when there are engineers or technicians are very specialized skills. Second, expensive process material means like oil and gas, very expensive, and very sophisticated control needs, because their sophisticated control needs means you require accuracy, safety, reliability. All these needs are required for that applications, and normally in the offshore onshore platform it is required. So mainly this focuses on the oil gas onshore and offshore applications. Application of these include offshore oil production platform, same thing is mentioned here, where the cost of stationary personnel is very high. Then second application is the pharmaceutical plants, where the chemicals are very valuable and maybe hazardous, pesticides and all. And aerospace applications, where the process response time are measured in milliseconds. So their accuracy is important in the airplanes. So earlier the applications were focused in these critical, or we can say critical applications, hazardous, critical. As we have learned in actual application, these industries are very interested in intelligent control systems. But the chemical process industries like RCF or other chemicals, textiles have a control profession that are just daunting, because they cannot afford these systems. But I'm talking about at the when the wall was launched. Now the situation has changed, and the costing has come down and reasonable to use in the other industries also. Specific problem that the intelligent control system wall has solved include measuring the flow of vent material from nylon or autoclaves. These are some applications where initially it was launched. Controlling the flow of dimethyl tereph, I mean, these are the refineries, DMT bottoms from steel, and preventing backflow in polymerization reactors. So if you see here, oil, gas, and pharmaceutical, they were earlier it was applications were initiated. And in addition to better control and lower installation cost, intelligent wall system with the process sensors can be used to diagnose process problems, because it has the sensors, temperature, pressures. Through that, you can diagnose the process variability. For example, by looking the relationship between the upstream pressure and flow, an intelligent control wall can detect a pluggage or pump wear as the system degrades. It can also detect a seat wear, means control of seat wear in the wall, and alert maintenance staff to replace the trim. So you can see here, you can plan the maintenance. Okay, the wall is now degrading based on upstream and downstream performance and flow rate. Finally, if the intelligent control wall can be programmed to monitor the process and bring it to a safe condition in the case of process upset or other problems. So you can have a interlock, or you can configure these walls, filbus walls, for safe condition. Means if the plant stops, the wall has to be closed, for example. So it will be automatically close the wall in the power trip or any other condition. Plant has trip, the wall has to close. For example, if communication with the DCS are lost, this is one problem it is mentioned because of many reasons. With lost during a batch, this system could program to hold the batch at a safe point and not take a chance to ruining material, or causing the condition that could endanger the operating personnel. Means to avoid batch has to be stopped instead of going to the waste reaction. If something happen further, and that product either it has to be damaged, or you cannot recycle, like that type of process is there, or that can cause the operational hazards. So smart wall put in maintenance savings. Predictive and preventive maintenance programs featuring the microprocessor driven diagnosis system that could save the substantial dollars in repairs and product losses. So, as I mentioned, some application it will reduce the losses, stop the losses. Even your plant stop, there's no problem, but it will stop any equipment or any human hazards can be minimized. So, eyeing potentially significant savings in maintenance cost, plant and corporate managers are demanding improved process equipment with the built-in or add-on diagnostic capability. So, everybody wants these diagnostics on the walls. So, wall-equipped suppliers are responding with the smart or intelligent wall positioners and wall systems, which have a potential to deliver major benefits in the areas of preventive and predictive maintenance. So this, as I told earlier, wall has no diagnostics available. Now, as I mentioned in the 2 3 slides, it has a it acts as a controller. That way, it is a preventive damage and even predicting the degradation of the walls, mechanical parts, dramatically reducing the maintenance cost and product losses which may otherwise result from the malfunctioning equipment. If it was not, suppose this was not available, the wall will remain as it is working, and one day it will stop. But if it is not controlling required flow rate, then your product quality also hampers. That way, you are putting extra cost on the your process, and at the same time you get a lower or a higher grade product, and that also costs the company. So preventive maintenance, an older technique used in the earlier, this is called a reliability based maintenance to increase the equipment uptime and lower cost. So reliability of the equipment, but here your maintenance reliability. So in the control wall maintenance reliability you can achieve by this intelligent wall positioner. That is what it is there. So preventive maintenance is what an older technique used since 1916, which typically requires completely shutting down a chemical process after a year or so to check out the equipments. So normally still this is happening in the industries every year around April May, or 15 days 1 month, depend on the uh, equipment or process equipment change. Shutdown is there, so entire factory is stopped, and electrical work, civil work, mechanical work, process related everything is carried out. Means this is the what a preventive maintenance. Total check, entire walls should be calibrated, removed from the line, clean, tested, calibrated, wherever required, it is replace accessories like this. That is called annual shutdown. That is called a preventive maintenance. Predictive maintenance, which is currently performed predictive, because that time predictive maintenance you don't have any information or data available. I'm talking about earlier days. Now Predictive maintenance, which currently preferred, it involves some 40 different technologies. In recent years, with the goal of predicting failures before they occur and replacing faulty device without having completely shut down a process. So this is what a predictive maintenance benefit. So you know that the wall is degrading, so you will plan a new wall, and you just isolate and you just prepare with a short period. You can bypass the line and install it. So that way, you are not completely stopping the process. That particular section, for a certain time period, maybe 4 5 hours, you can bypass it and control through other parameters. So this is what predictive maintenance, and which achieved through the smart wall positioners or intelligent wall positioners. Proactive maintenance means which puts the human element into the equation, looks for a root cause failure analysis, for example. That is a proactive. Then reactive maintenance, or responding for a emergency, means reactive means when the wall has stopped, remove it, and that is a reactive maintenance. Mm. So why I have explained, because in the control wall, a lot of maintenance was happening, and now we are getting uh, relief through this technology. uh, and the terminology used is a predictive. Smart positioners handles a digital or analog signal. So here we have seen HART, if it is there, it handles analog signal and digital also. So microprocessor based wall positioners, like a smart transmitter, accepts either analog or digital control signal. Typically two wire products, as you have seen the smart transmitter, two wires. They have onboard microprocessor. We have seen the microprocessor, transmitter, CPU board, input sensor board, and display board also. So there you have seen they have onboard microprocessor for functions such as wall characterization, diagnostics, alarm definitions, and similar tasks. So on the microprocessor, you will get these functions. Unlike a smart walls, smart positioner do not include sensors, and therefore do not offer multi-variable process measurement capability. So smart positioners offers many benefits over conventional positioners. I'm talking about a pneumatic positioner, including remote access, predictive maintenance, diagnostics, and overall feedback of wall condition. So smart positioning improve the operation by making it possible to access positioners remotely. So you can access the positioner through Modbus, as well as diagnostic problems, and discover the degradations that could cause future failure. So you can in advance come to know. So smart position can also be used to detect changes in actuators, positioner, I2P performance, and this allows the user to see the performance changes in a fault pump or the pressure drop across the fouling of the pipelines. So because of these inputs, we can say crucial inputs, you can detect the equipments in the line, like a pump or pipeline damages. Because pump and piping means, due to corrosion, some foreign particles get choked in the walls, and you will come to know, due to the smart wall position pressure measurements. So that is what it is mentioned. So I have explained you about how these new technologies Philbus helps for predictive maintenance. So now I'm coming to the digital signal. HART positioners are using analog signal. Fieldbus positioners are using digital signal. purely no analog signal. So as the international fieldbus standards are established, controllers with the smart positioners will be able to communicate even more in information. With the fieldbus, smart positioner will be able to integrate control input information, wall position status, and auxiliary sensor input such as air supply pressure and packing and gland pressures. So if you see the control wall, these are the maintenance areas, packing, gland pressure, glands, and all. They, that inputs are available, and really, the degradations or any leakage, you can detect it images. So onboard intelligence combined with these input variables will enable a smart positioner to provide information to the control system to change a process or anticipate and schedule necessary maintenance and repairs. So your replacement planning you can plan based on these inputs. So that is what these wall positioners are uh, giving a benefit to the industries. So with this, I think there are certain diagnostic features available here. You can see your step signature. This is one of the important part. S- The step signature means what? The step signature means a step signature is generally run to diagnostic problems on an on-off wall, while a ramp signal is used for throttling walls. Step means logic 0, logic 1. These two steps. In either case, the user defines the starting and ending wall position for the signature and how long data should be gathered or for lateral analysis. So when wall is off to on, that change, that time is also measured. Signature, or we can say, you can plot the graph. Signature data differs from historical data. Means earlier, suppose when wall is new, for changing from wall on to off, the time required. But after some days use in the plant, that due to the hysteresis and other mechanical degradation, this data changes. So you can see here, in the case of signature data, the wall movement is defined by how signature was set up to run. Historical data, on the other hand, is gathered while the process control is setting the wall position. So you'll get its history. So this distinction is important because the user must recognize that the process will be upset while signature acquisition is being run. So you will come to know it takes a time. In a step signature, starting and ending wall positions are defined as is how long the data is to be recorded. So earlier it was suppose 1 second, then it is taking 1.5 second like this. And if this 0.5 second difference is there, that will affect your process. RAM signatures. RAM signature gathers the same data in the step signature except the step command sent to the I2P converter change to the I2P converter changes to the rate defined by the signature dialog box. So data is gathered at a 50 millisecond interval and also include the gas or liquid flow rate through the wall. The system is designed to provide significant savings in the compressed air cost. So one of the application is mentioned here, benefits achieved in the compressed air. When a wall malfunctions, the alert system flashes two LEDs. When the wall malfunction, the alert system flashes two LEDs. There are two LED indicators on the wall. Both open and close switch circuits energize simultaneously to alert the control computer to a problem. So in the control system DCS, you will get alarm. The system is designed to also detect fugitive emissions and air supply pressure problems without additional wiring. So in the built-in, it detects emissions because the wall is used for some hazardous gases. So and it is leaking. So that leakage immediately detected, and you will get alarm in the field also, as well as in the control room or in the fire side, fire team. So receive input from temperature, flow, or level switches. It can speed installation by altering personnel. So that is what I mentioned. Inform the personnel to of improper wall setup, reduce troubleshooting time, and identify sluggish wall operations or torque requirement. So response time also, if it is sluggish, so that will be also you can rectify the problems, because you get a through the step and ramp signature, you will get a uh, analysis. Through that signature, you analyze your uh, problems of the wall. So I think so far I have explained the benefits of hard positioner, benefits of feedback positioners. One we can say based on analog digital, another is only digital, or one is a smart, another is a intelligent. Like this we define. Now I will show you uh, some electro mechanical parts, technology how develop uh, for reducing the problem in the linkages. You can see non-contact position sensing. Earlier, you pneumatic positioners you can see, or even hard positioner. You I have shown picture where stem and there is a one link here. You can see like this linkage. This I have shown you, but latest walls are coming with a non-contact position. Means there is no contact. This is not there. So mechanical linkage, feedback parts can stick or gall, vibration effects, poor accuracy, shorten operational life for this, shorter risk of personal injury in this. So these are the existing wall positioner with a contact type of a stem linkage with a positioner. When we go for non-contact, you can see here non-contact position sensing. Completely digital, higher accuracy, no mechanical coupling, less sensitive to vibration, no linkages, less hysteresis, no enclosure protections. So you can see here magnets are there. This is a wall stem, and this you can see magnets here. Here, so this way accessory is there here. This is a non-contact. Hmm. So the old way of sensing positioners, old way, wall stem. This is a feedback lever outside positioner, this one. And there is a scale on the wall here, which show wall open, wall close, and this potentiometer through axis inside positioner, this one, like this. So you can see this is the yoke pin here for fixing, like this. So wall stem movement was mechanically transmitted. What was happening here? Wall stem movement was mechanically transmitted to a potentiometer using a lever sliding over a pin. This, so vibrations are transmitted, causing the potentiometer to fail here. Gaps and imprecision cause errors. Here we have loosened the screw, the gap, and enclosure penetration subject to potential leaks, like this. So these are the existing positioners problems are happening. When we switch to the linear non-contact positioner sensing, how it is working, you can see here. This is the wall stem. This is, you can see scale on this yoke. open and close position, and this is a pointer moving up and down, right? So north and south pole magnet here. Here also, this is north and this is south. And there is one sensor on this plate is called a Hall sensor. This sensor, or we can say this sensor. So now wall is a closed position, right? See, and here the wall is on open position. Oh, like this. So you can see here, no mechanical coupling, less sensitive, no linkages, less like this. So like this, it is installed like this. So wall travel output like this. There is a rotary non-contact positions are also available. Rotary wall for rotary. This. So in short, the technology is moving for wall positioner is a non-contact type based on the magnetic Hall sensor technology. Hall sensor. So in earlier days, we have this pneumatic positioners. 1994, we have this transmitter, HART transmitter. Increasing shape and flame-proof positioners are, these are the approvals: Senelec, DMT, FM, CSA, weatherproof, IP67, high EMI, RFI immunity, and Lloyd approvals. So these are the approving agencies for all these walls positioners. So here one wall positioner is shown, and that is of SMAR. This is the wall positioner, you can see this one. Air supply regulator.
Mhm.
Hello.
Hello,
Ah,
sir.
huh.
Is it finished?
We can stop or what? We can.
Yes, yes.
Tomorrow we will continue. Right?
Okay, sir. Okay. Thank you very much for
Thank you.
sharing
Okay. Thank you.
and taking this nice session.
So
Thank
thank
you
you.
also.
Thank you. Thank
Okay,
you.
sir. Thank
Thank
you.
you.
Hello.
Hello. Thank you.